Good afternoon, everyone. Welcome to join this session. Today, I'm going to share with you about the edge-optimized architecture for fabric defect detection in real time. My name is Shu Quan, come from 99Cloud. At the beginning, I will give you a brief introduction about 99Cloud. 99Cloud was founded in 2012. We are the largest OpenStack training organization in China right now. We start our business with training, and then we use OpenStack as our core solution, providing the cloud services to our customer. We are members of many open source communities such as OpenStack, CNCF, Linux. We continuously contribute OpenStack since 2012. We are the top 3 contributor in China. We have largest OpenStack market share in China in many industries such as energy, financial, banking. Today, I will talk about the edge computing in manufacturing industry. As you see, the compute history, we started the concept of time sharing in 1960, and the cloud computing has dominated the IT discussion for the last 2 decades, particularly since Amazon popularized the term in 2006 with its release EC2 services. At the same time, 2010 OpenStack comes out. We have the open source solution help a lot of companies can build a cloud solution by themselves using OpenStack. Edge computing has also been a driver innovation with OpenStack, the open source cloud computing project. By using OpenStack right now, we can have the public cloud, private cloud, hybrid cloud, and the cloud can be massively distributed. Even though right now we are centralization of all the computer services in the data center, but in the future, with the emerging requirement of the AI, 5G, and smart city, we believe cloud computing will evolve to edge computing. So, do we have the edge computing use cases when the cloud still dominates? The answer is yes. CDN is a very popular solution in cloud computing. With CDN, actually, we can get the video very quickly, and we can download the application very quickly because CDN can help us to get the material very closely. Actually, we can think CDN is a edge computing. Let's see the working mechanism from the HTTP request. Without the CDN, the browser will request the web server directly, and the web server will return response to the browser. So at this time, if we have some large video, then the large video will be downloaded directly from the web server, even though the web server is far away. It's a huge latency in the network and cause the heavy bandwidth, heavy traffic in the network. If we deploy the CDN server, then the browser can request the CDN server first, and the CDN global load balancer, he will find a region CDN load balancer for us, and the region CDN load balancer will get the nearest CDN cache server for us. We will get the material from the local CDN cache server. So the CDN actually is solution for us in the cloud computing, even when the term is cloud dominate. So this is a very simple example, help us to understand what's edge computing. So the emerging requirements and workloads are beginning to expose the cloud computing's limitation. For example, the smart city, the augmented reality, and virtual reality. Those applications, they require they require a lot of requirements such as low latency and high bandwidth, which is the application in cloud computing do not consider it. So there are two factors driven cloud computing will evolve to edge computing. It's actual factors related to the use cases and the internal factors related to the limitation itself of the cloud computing. As we know, the edge computing can provide four major values for us. The first one is highly responsive cloud services. The second one is edge analytics in IoT. The textile industry is one of the significant examples. I will share it later on. And the third one is to exposure firewall in the IoT. We can have much secure environment by enable edge computing. The fourth is to master disruption of the cloud services. I just said that Industry 4.0 actually it connects all the IoT devices with the manufacturing. And this is a very good opportunity for us to investigate the use cases of edge computing. As you see, for centuries, all the goods, including foods, clothes, houses, they are manufactured by hands. According with the industry improvement to the Industry 4.0, all the manufacturing devices, they will connect it together. How can we put the intelligence into these devices? Edge computing is the key. Why? We believe edge computing can act as a nerve ending of the manufacturing. The nerve ending can have act as an intelligent agent in the layer above the sensor. If there is only sensor, the sensor can just collect the data but do not have actions. With edge computing, we can collect all the data and do the real-time analysis when we have the data. So it's a very low latency actions when we enable edge computing in the manufacturing. And we also can reduce the bandwidth in the network. The edge side, it can collect all the data, extract the features from the edge side, and just sending back the features to the cloud. The cloud can do the further analysis and run the more complicated machine learning algorithm to help us get the further results and pushing back the intelligence to us. So let's take a look at the general architecture design of the edge computing. We have three parts in this architecture. First one is cloud computing. As we all know, it's a very traditional cloud architecture. You can use many technology like OpenStack, Kubernetes, and on the middle, we can have edge computing software stack. And in the end, it's a data source. We use the IoT devices to collect all the data source. And in the edge side could be different footprint. If the footprint is larger, we can deploy OpenStack on top of it. And the OpenStack will help us to manage the larger footprint. You can even deploy, like in some telco cases, you can even deploy a full OpenStack deployment in the telco central office. And in some small footprint, you can only deploy some container in these devices. And we can run the data collector, data filter in this edge infrastructure. And in the cloud side, as I just said, it's traditional cloud technology. You can deploy Kubernetes as a platform of container. You can use the Ceph as the storage, and you can also use OpenStack as well. How this cloud computing, edge computing, and data source get connected? For example, from the IoT devices, we can use the you use different protocol such as the Zigbee, the Bluetooth to sending the data back to the edge computing infrastructure. And because the edge computing infrastructure is very close to the IoT devices, so they can sending the real-time actions to the IoT direction for some operations. And from the edge computing to the cloud computing, there are also many protocols you can select. For example, if it's wireless, we can use Wi-Fi, LTE, GSM, and we can also run the MQTT on top of it. If you have LAN connected, you can use the 1 GB network or 10 GB network to get all the edge side and cloud central cloud get connected. And cloud computing, it will collect all the data and do the more complicated analysis and pushing back the intelligence to the edge to update all the model and some data in the edge computing infrastructure. So let's take a look at the textile manufacturing process. As we all know, the textile manufacturing actually is a process to conversion the fiber into fabric. And first of all, we will spinning all the fiber into a yarn and weaving all the yarn into the fabric. And then we will dyeing and printing the color and the patterns we want to the fabric. At this time, we only get a very basic fabric. It's just finishing, but during the manufacturing process, we may get some flaw. So we have another very important process, inspection. We have to inspect is there any flaw or defect before we deliver this fabric to our customer. So the human, traditionally we are using the human to inspect the fiber, which is high cost and low efficiency and high cost, low efficiency and inconsistency. Human inspector cannot detect the error because the careless and illusions or because the defect is too small, and also it will we cannot get the consistent result from the human because human will get tired, right? Also, we would like to have another automation system which can help us to find is there any defect patterns we recognize and use some machine learning algorithm to recognize them. So traditionally, we develop in the textile industry has this kind of systems. It can help us to resolve the defect problems. Let me introduce the three major steps of this detection. The first of all, we have to capture the image of the fabric, and then we have to run the algorithm to detect the defect. And afterwards, we have to do some post-processing. So the image capture procedure is majorly responsible for some defect samples capture, and then we will use a high-resolution camera to capture many images of the surface of the fabric. And the defect detection procedure is performed to localize and segment the flaw regions. And sometimes it also includes the quantity analysis. The last post-process procedure is to help us to classify all the defect types and assess the grade of the fabric, or even we can to operate some machine to remove the defect automatically. But let's look at the traditional architecture. As I show in this picture, it has two drawbacks here. One is it costs very high bandwidth in the network, and when the central cloud wants to operate the machine, it's high latency. Why? Because we use high resolution camera, it captures a lot of image. We have to send all the image back to the central cloud for further analysis. The image size is very huge. When keep sending all the images in the network, it costs high bandwidth. And because a manufacturer, they may have many workshops. The workshop may distribute it in different cities. So when the central cloud would like to control the machines, it takes time to sending the command to the workshop for further options, such as the defect remove. So we can optimize this architecture with edge computing mindset. This picture is showing we are adding the camera in the machine to capture all the image, and we're also adding another control machine which is responsible for the edge cloud besides the machine. We are putting some data analysis, data feature exception module beside the machine, and it can also control the camera, the lens, the light, and the printer beside the machine. So in this edge optimized architecture, the images will be only sent to the edge cloud, and the edge cloud, the application running on this edge cloud, it will extract the features of the images, and it will run some basic mapping program to find if there is a defect of the fabric. Also, this edge cloud will sending back the features to the central cloud. The central cloud will get all the features back from many workshops. It will do the further analysis and update this pattern and model again, and it will regularly sending this model back to the edge cloud in every workshop to update them. So after again and again, we will get a more precisely prediction for the fabric defect. And by using this edge optimized architecture, we can avoid the high bandwidth in the network, because only features sending between the edge cloud and the central cloud, and the image can be processed in the edge cloud. And when we plan to control the machines in the workshop, we can use the edge cloud to control it. It's low latency. So this is a more clear picture for the whole setup. You see there, we can put the edge cloud just in a small box beside the machine, and the edge cloud, it controls the light, control the camera, and when the fabric is in scoring, the edge cloud can locate the defect, and also it will print out all the reports in real time. So this is more detail for the design. As you can see, in this picture, there are a lot of camera they are putting on the machine, and the camera will connect to the frame grabber, and it will get the image data. In the edge cloud, the image capture module, it will control to the frame grabber, and it will at the same time connect with other encoder, like get the metering data from the fabric render. And when the image capture get all the image, it will run the mechanism in the edge cloud locally. The mechanism and the pattern or module, it will get update from the cloud, central cloud. And the defect detection module, it will running the result and sending it out to the monitor for the worker to see the result in real time. And if the worker wants to report immediately, he can just send the command to the edge side, and the edge side will get everything printed out. So we are working this solution with our partner in manufacturing along Shanghai, China. We are find the traditionally textile quality is human-oriented analysis, and nearly no system can be used to operate the weaving and knitting machines. It is because the control is far away from the machines. So with this edge-optimized architecture, we demonstrate that there could be an automatic and real-time defect detection system can be built to increase all the efficiency of those manufacturers. We can automatically capture the defect image and get a report of the defect. We can also get precisely the defect position, and even we can operate the machine in the real time to remove the defect. So during our POC, we found that our system has 5 to 6 times to the humans. Normally, when the fabric is scoring, the speed of with human inspection is about 20 meters per second. But with this automation system, we can speed up to the 120 meters per second. So that is a huge improvement for the textile manufacturing. This is also a very example for edge computing, how to optimize the traditional cloud computing. With edge computing, we can have our application with lower latency and can do the IoT analysis in real time. So this is all I'm sharing today. Do you have any questions? Yeah, please go to the mic.
So this is really an excellent use case.
Thank you.
For the edge computing, the image processing for fault and fault detection, that's okay. But do you have like a mini data center, or just the box, the product itself, or what?
Yes, there we have some building patterns.
Yeah.
Yeah, for the floor, and we will, when we set up the edge cloud by the machine, we will just put the building pattern in the box, and for the phase 1 analysis, and again we will keep sending back the features to the data center of the manufacturer. So the manufacturer will collect all the new features, and it will keep updating the building data set and to improve the prediction.
So is that data center is in the edge cloud or is in the central?
In the central.
In the central.
Yes.
And the distribution of these machines is geographically distributed closest to where that you do the production, or what?
The edge cloud is close to the machine. Is belong in the workshop of every manufacturer, and each manufacturer, they have a central cloud. Is operated by its IT department.
And those clouds are served by like China Mobile or some bigger?
No. It's private cloud.
Private cloud?
Yes. But it's case by case. In this POC, the customer, they just have their private cloud, but we also learn that some manufacturer, they have small scale, they use the public cloud, such as maybe Ali Cloud or some other cloud.
And the number of these machines or local operations, there are like hundreds or thousands? What is the scale?
You mean the central cloud?
No, the local machines.
local machines. They are for the medium size manufacturer. They have the hundreds of the weaving and knitting machine, and for the small, they have dozens those machines.
Even the smaller ones, they go with this architecture, or they can just handle it.
Yeah, if the small manufacturer, they may have only 1 or 2 workshops. They are close together. They can just deploy the central cloud.
Right there, yeah.
Yeah, just beside them. But for medium size or larger manufacturer, they have a lot of workshop located in different cities. So they have to use this edge optimized architecture.
And in that case, you can do the all the communication with central cloud through Alibaba, yeah?
Yeah, in theory, we can.
But that, have you identified any issues, like security issues or some other issues with using public cloud?
Yes. So the customer, especially for the medium and large manufacturer, they tend to use the private cloud because of the sensitivity of the data. And for the small scale manufacturer, they do not have the IT teams to help them to operate the private cloud. So they have to use the public cloud. When they grow, they will ask for the private cloud solution. And as a cloud solution provider, 99 Cloud, we provide them both the edge cloud and the central cloud solution.
One last question maybe. When you collect data, could you go back to that slide that shows the collection?
Which one?
The data that you collect and then send. What is the mechanism that you use to send the data? You measure the data.
This one?
Yeah. Oh. You measure the data, correct?
Yeah.
And then you need to send that data to a collection point and don't process it.
Yeah.
That communication, is that shown here? You said that...
This one is a general solution for this particular cases.
Data collection, okay.
Yeah, data collection. Because you see here, let me show you. Yeah, here, right? Because this edge cloud is close to the machine. So the machine has the sensor. We can directly use LAN to connect to the compute. For example, we are control the light. We can use the GPIO interface to control the light, and we can get the metering information from the sensor of this machine. We can directly get from the machine, and from the camera. Right now we use the IP camera, so we can connect the connect the LAN from the camera directly from the computer. Use the LAN to connect the image data.
Yeah, but in general, if you want to make it more scalable, don't you imagine that you have a massive deployment of this system? It's even like maybe thousands or hundreds of thousands of this, probably 10,000 of these. What is the mechanism that you send your collected data to that collection point? Because we are actually using this as a use case. Have you thought about a specific mechanism that how would you send that data? Or today is all LAN connection, yeah? But yeah,
tomorrow, I think we will provide several options based on different cases. In manufacturing industry, a lot of machines, they provide the LAN connection. So if we can use LAN, I think it's better because it's more stable. And some of the industries, such as the lighting in the city, smart city, right? They are wireless. So we have to connect them to the data point, use LTE or LoRa, that kind of protocol. So that, I think there is no specific solution for them. You have to look at your use cases and think about which kind of connection is better, can be performed.
We are looking at the serialization using like protobuf with the gRPC, but you don't have that problem here.
Yeah, in this case, do not have that kind of problem.
But you are not thinking about the future if it's a massive scale problem, then you need to look into some other mechanisms. Yeah.
Yeah, I think you're right. For the future, for more massive distributed, there should be a mechanism to resolve that. Yeah. Thank you. Thank you for your answer. Thank you. Is there any other questions? Okay, thank you.